In 1982, Commodore was at a crossroads. Their lineup consisted of the vastly successful VIC-20, which was regarded as the best-selling home computer of the time.
Why buy just a video game from Atari or Intellivision? Invest in the wonder computer of the 1980s for under $300, the Commodore VIC-20. Unlike games, it has a real computer keyboard. With the Commodore VIC-20, the whole family can learn computing at home. Plays great games, too. Under $300, the wonder computer of the 1980s, the Commodore VIC-20.
They also had a successful lineup of business machines built around the Commodore PET and the new CBM2 series. Their competitors didn't sleep though. IBM had the PC for businesses, Atari had a great 8-bit lineup, and Apple continued to sell the Apple II for both home and business use. One machine that particularly bothered Commodore's CEO and founder Jack Tramiel at the time was the Atari VCS, which still sold very well in 1982, even though it made its debut as early as 1977.
Only Atari makes the world's most popular home video games. The only Space Invaders. The only Asteroids. The only Pac-Man. The only Missile Command. And soon, the only Defender. And the only way you can play any of them is on a home video system made by Atari.
Its concept made it a pure gaming console, and its price point was very low at the time, so it sold many units every year still. Legend has it that Commodore tried to hinder sales by deliberately slowing down production of the mask ROMs for the VCS cartridges. MOS Technologies, which had been acquired by Commodore in a previous business stunt, produced these chips for Atari, which in itself seems kind of a strange decision by Atari, but that's a different story altogether. Commodore previously had made some plans on how to compete in the gaming console market. Their engineers developed the next generation of video and sound chips with gaming on their minds. Designed by Commodore engineer Al Charpentier, the now famous VIC-II with 16 colors, high-res graphics, that's 320 by 200 pixels, 8 sprites, hardware collision detection, and other great features seemed like an ideal chip for gaming. Commodore engineer Robert Yanis had developed the SID sound interface device, which would soon become recognized as the most advanced sound chip at the time, and remained in that position for several years. Despite its imperfections, it is still highly regarded today. Japanese Commodore engineer Josh Terakura, who had just finished work on the VIC-20 computer, pitched the idea for a gaming system to Jack Tramiel. Tramiel gave him the freedom to decide on how he wanted to design the new platform. Meanwhile, the American Commodore engineering group was struggling with developing the next generation P and B business machines. They wanted to build more powerful machines, but dynamic RAM was not fast enough for what they had in mind at the time, and a number of other problems hindered the process. In the end, the engineering team was not very convinced anymore that the new machines would ever be a meaningful addition to the lineup. Terakura remembered the VIC-II and the SID chips, which were initially designed to be used in game systems, and decided they would be ideal for a games machine. He aimed for a low-cost, high-efficiency gaming system he dubbed the Ultimax. Terakura moved to Pennsylvania to work on the device. He was granted total freedom and did not have to report back to the American engineers. He took over the project and quickly came up with the architecture for a low-cost machine using the new chipset. He encountered the same problem as the other engineers with DRAM being too slow, so he decided to rather use static RAM and to design a modified version of the VIC-II, the 6566, which could operate with SRAM. The low price point should be achieved by having only a membrane keyboard and especially cutting down on RAM and leaving out any ROM from the machine. The engineers planned to use only 4 kilobytes of RAM, while the software designers demanded at least 8 kilobytes to have something usable. Tramiel got wind of the argument and proposed 6K as a compromise, which did not help either group. It was finally decided to only put 2K of RAM into the machine. It would use cartridges as the main means of loading software anyway, so the ROM and RAM should live on the cartridge rather than in the machine itself to further cut the cost. Tramiel liked the idea, but also felt like Commodore needed a successor to its most successful product, the VIC-20 home computer. The American design team took the Ultimax design, added some DRAM, a serial bus, several I/O ports, and the option for onboard ROMs, and put it in a case very similar to the VIC-20. This machine, initially called the VIC-40, would later become known as the Commodore 64, named like that for its gigantic memory, for the time that is, of 64 kilobytes. While the machine had a slightly different architecture than the Max, it still had a compatible Ultimax mode that configured the memory to behave like a Max machine so the cartridges worked. The rest is history.
In January 1982, the Commodore 64 personal computer was introduced with a 64K built-in memory for under $600. So to stay even with Commodore in memory and price, IBM will have to slash its price, quadruple its memory. Apple will also be faced with a sizable chore, and so will Atari. As Shearson American Express put it, the Commodore 64 could be the microcomputer industry's outstanding new product introduction since the birth of the industry.
The machine the engineers at Commodore Japan designed was meant to be released worldwide in early 1982. It ended up only being released in Japan. Some units made it overseas, but there were only an estimated 50,000 units produced overall before the machine was discontinued. It was sold simultaneously with the release of the Commodore 64, and although it was a lot cheaper, it could not really compete with its bigger brother. The product was called the Commodore Max, or Max Machine, and featured a 6510 processor, the new VIC-II and SID chipset, and 2 kilobytes of static RAM, plus an extra half a kilobyte of color RAM. It had 2 Atari-compatible joystick and pedal ports, a membrane keyboard, and came in a fancy-looking silver and black case. Similar to the C64, it used a 6526 CAA chip for everything input and output related. It also had a PLA chip, the MOS 6703. It had a connector for the Commodore datasets like all the Commodore machines of the time, although there was no real use for it except for saving BASIC programs. BASIC came on a dedicated cartridge, due to the lack of any ROM and the shortage of RAM. There was no ROM in the machine, so every little bit of software had to be included on the cartridges. The power supply delivered the same voltages as the one used for the C64, 9 volts AC and 5 volts DC. It was designed for the Japanese market, so it operated at 100 volts AC input. The sound and graphics output was achieved through an RF modulator to connect to a standard TV via the antenna cable. Although the Commodore Max was a very short-lived part of computing history, it paved the way for what would become the most successful single computer ever, the Commodore 64. Josh Tirakura, Rob Janis and Al Charpentier, along with the rest of the Commodore engineers, created what would become a true legend.
Rather than compare personal computers ourselves, we asked the computers which one was better on the basis of price and memory. The Apple II preferred the Commodore 64. Then we asked the IBM, and it picked the Commodore 64. Then the Radio Shack chose the Commodore 64. That's what we like about our competition. They're so honest. The Commodore 64, what nobody else can give you at twice the price.